LeetCode contest 293 from a few weeks ago. So do this one virtually this morning. Here we go. Open these guys up. Okay, find results from random removing anagrams. Anagrams. The one next to it, like adjacent neighbors are anagrams, all right? Delete the one. Let's see. Okay, so it looks like we can delete right to left based on a map, right? So, okay. After 4 a.m. The game plan is to use a map to count each word's character frequency, then reduce from right to left. All right, so 4 a.m. to however long it takes here. That's for implementation. Oops. Okay. Vector strings. Oops. Shorten this up a little bit. So this is our array of words. Or string in the array. We'll create a map for it. Actually, let's see. Yeah, we can refactor it later. But yeah, let's just use a map. Count a map. Actually, we want each word have its own map. That works, right? Maps equals vector of map, whatever. Maps and for each character in the string. Let's see. M dot place back. Just an empty map, and then M dot back. Oops. C. Like that. Okay, so for which ones we want to remove? I think we can probably just erase it, right? Erase, remove this, right? So erase. So remove this string. Actually, let's do this. Let's just do the, let's keep it easy, right? So each index I, and using the I as a vector of integers, move Okay, actually, we want to go from n-2 downwards, right? Size. Go down to 1, right? Okay, let's do this. Low anagram. Yeah, let's just do this. This is easier, right? We'll just have a map for each anagram. If it is anagram, then we'll just remove it. Is it? It's not that efficient, but whatever. It doesn't have to be perfect, right? So adjacent strings with their anagrams. We'll remove, mark one of them for removal. This is kind of ugly, but whatever. Nice, remove, and return A at the end. And okay, so I guess 1. So previous one, the current one, right? I want to do. Okay, I want to do that. Hold on. Remember, sometimes, yeah, going definitely. I just so going slow, slow sometimes, right? Remember to KSS, keep it super simple, right? So I could just use a string too, right? Just create a string. String or a map or encode it somehow, right? Oh, why not just sort them? Duh. Holy cow. Okay, yeah. So here, let me just abandon this. Right. Obviously, we just sort them and then use the string itself for comparison. Hold on. Keep it simple, right? Okay. Okay, down to 1 inclusive, 0 non-inclusive. See if that one's an anagram. If it is, then we'll delete the current one, right? Okay. S equals a sub I minus 1. T equals a sub I. All right. Sort S dot again, end, sort T dot again, T dot end. If S equals T, then we want to mark it for removal. Suppose we'll just skip T. We create B for me, right? If S does not equal T, then we'll do B dot replace back T. These first. Hold on. Actually, we need that to be a deck, right? Well, it's going to be reversed. Right. Yeah. All right. Deck B. Place front. Actually, let's just mark it for removal, right? That's okay. Just mark the indices for removal. Right. We're never going to remove the first word, right? That one has to stay. Okay, so that should be, well, I mean, this works, right? Okay, I was thinking just use A without using A and B, but whatever. Okay, so and C D. Oh yeah, and then we want to do V dot. Oops, that very last one. Place front face of 0. That one always goes there. It looks good. Oh. Oops. Okay, hold on. I sorted it and then modified it, right? So place I. It's a copy that's sorted. This is the original. Okay. Oh, hold on. It's how many minutes? It was 6:05. Let's see. $11 minutes implementation, which results in the wrong answer. Right. KRU. That's right. Okay. Yay. Okay, and then I don't know, it took me like 1 minute to fix bug. I return the sorted string rather than the unlocked. All right, this is like my hash key comparison. Right, anagram comparison. Okay. The other option is to use a vector of integers for the indices to remove. Right, and I think that might be a little better. Remove. Right. Move dot push back I. Actually, it'll be a set. Let's just do this set moving set for all one lookups. Set of indices to remove. Insert I. Okay, and then A dot erase. Remove if again. And let's see, -1. We don't even need this thing. Immutable. If move dot find, this was I, let's not go remove and I'll move it. That guy. And okay. And then return A at the end. Okay. That should work. Oh. Remove cannot be implicitly captured. That's right. And then, yeah, that's fine. Looks good. Uh-oh, that is not looking good. Really? What the heck? What the heck happened here? Hold on. That was right. I didn't look closely enough, obviously. Oops. Well, moved the CD, but didn't move these other ones. The heck? Oops. Hold on. Let's just print this out. Okay. Okie dokie. These are removable indices. I'd expect 1, 2, 3, 0, 1, 2, 3. What? Oh, wait, hold on. If it is equal, then we'll remove out. Okay, so backwards. Somewhat of a double negative, right? No, that's not right. 0, 1, 2, 3, and 4. How is this possible? That doesn't look right at all. What? Why is it not deleting these? 1, 2, and 4 is what it should delete. 1, 2, and 4 is correct. It's not deleting 1, 2, and 4. Why is it not deleting 1, 2, and 4? That's weird. What the heck? 1, 2, 4 exists and remove. Right? I'm printing it right here. Okay, so I don't get it. I don't know. Let's see. Copy if a dot begin, a dot end. On so remove my reference. Need that thing. Immutable. Copy this thing, that thing. Insert B. Turn B at the end. Turn, remove, find, it exists within remove. Wait, this, hold on. Should be the opposite, right? It's not in remove, right? Oops, hold on. Copy if. Copy if. Back insert the output. Predicate policy. Predicate at the end. Okay, so hold on. Do this guy. Back inserter. P there, and then so if it's not in remove, then we'll keep it. That looks right. Okay, so that's cool, right? So copy if works, but remove, erase, remove if. The heck? Why does this not work though? This part works, but this part does not. Why? What the heck? This is so weird. What am I missing? It's the opposite of this, right? This is if it does not exist in remove, then we'll copy it. If it does exist in remove, then we should delete it. Doing this wrong? C++ erase, remove if idiom. Erase, remove, right? Right. Erase. If. All right, whatever. This really frustrates me. I should move on. I knew. Yeah. What the heck? I'm doing this exactly right though, isn't it? Hold on. So weird. This is so strange. Hold on. Let's make a copy of A. B dot erase. Maybe it just has to do with the online judge test. Redefinition of B. Yeah, hold on. No. Okay, so this code is fundamentally wrong somehow, and I don't understand why. Erase, remove, and whatever. This works. It's not that bad of a solution. It's not that good. We're using an auxiliary data structure where we don't really necessarily need to, but I guess we're not modifying the original input. So, ooh, pros and cons to everything. Whatever. We'll come back and fix it up if you need to, but I suppose it doesn't have to be perfect. And I would like to move on. So it'd be cool to be able to get to the fourth question. Okay, so let's see. Sort adjacent strings or anagram comparison. Actually, we don't have to do it right to left even, right? It's originally it's a little bit more complicated than it needs to be. All right, so let's clean this up a little bit and let's move on. Okay, so let's see, last string last. And we'll just copy it over right here. Let's do this. Copy it over to the answer. Okay. Just take my copy. No, reference, and then we'll copy it here and then sort. And if t last equals t, or last is not equal t, right, then we'll do and dot replace back last equals t. Last is sorted though, right? Last equals s. Modified, right? T is our target. Whoa, that's not right at all. Last s. Last equals s. Okay, oh, that did a lot of work. Last needs to equal t, then right, last is the sorted one. Right. Looks good. Okay, so that's a little bit more simple for sure. Quite a bit better solution, I'd say. Right. Yeah, that's good enough, right? That's cool. The other one's really ugly. Okay, let's move on, right? Code is a liability, right? It's not like something to perfect. Okay, so there we go. Already on 3. Right, let's keep checking where we're at. 621. Otherwise, I'm gonna just burn through the contest doing all this nitpicking. Let's begin for S and A, string A, T equals S copy sorted. Sorted copy of that string. Last equals should be okay. Oops. String. Okay, so if last sniper T answer dot and S. Oh, that's me. Okay, that was good. Yay. Okay, 621, 623. 2 minutes. 2 minutes. Minutes for implementation, which results in AC. Yay. All right, it's cool. Bam, bam. JavaScript. Words, last word. Word string of the array A. Answer. The answer in the end. T equal. Oops. T equal is a copy of that string. Make a deep copy of this thing. Just split it and join it. I'm not sure if that's needed or not. Yeah, whatever. T dot sort A B A dot cal compare B if last equal T and answer push S last equals T. Okay. Uh-oh. Sort is not a function. Oh, T. Okay. T equals T dot join. There we go. It's good. Okay. Kotlin. Sorry, words. Answer is equal. List of string. To list. For string in the input array A. T S dot is to copy of T dot sort. Sorted? That works maybe. If this empty string minus is not equal to T, then as dot add S minus equals T. Okay. Whoa. Little list out. Need a template thingy there. Uh-oh. Copy of to char array. That's sorted at join to string. Yay. Okay, that looks good. All right, taking a little while. I was wondering if I get out and push or not. Okay, here we go. There's that. Then Rust will be next. Okay, a little rusty on Rust, so let's see what happens here. Where's Rust? Is there Rust? Or there's Rust. Okay. All right, here we go. Let's go to the next screen. Clean this up a little bit. Okay, so that mutant equals vector string. It's from the end, and that was for A. And for each string A, let's see. Last equals empty string. That means T equals S dot chars dot collect into a vector of char. T dot sort. Sorted dot join. wonder if that works. I don't think so, but if last is not equal to t, then answer dot push s, and then last equals t. Tend to fix compilation errors. No methods sorted. All let's mute sorted equals this guy. Sorted dot sort. All right, let t equals sorted dot join. Does that work? I don't know. Join. Oh, sorted dot iter to iter. Does that work? Sorted dot into iter to join. Not found. Oh, let's see. Let's join character array to string. The iter.collect. Sorted into iter.collect. Expected to this mismatch types. Expected. Oh, no. String from string. It's taking a while. Oh, there it goes. Okay. Yay. Okay, cool. Not too shabby for us. Sometimes it gives me a real hard time. Okay, cool. Yeah, so sort adjacent strings for anagram comparison. I guess that is for each input string s. Create the target t. Compare. Yeah, last. Whatever. Sort of adjacent string for anagram comparison. For each input string, right? S right, of the input array A. Create the hash target T to compare, right? Which is just this sort of string. That's cool. Okay, not to be perfect. A few solutions. That's cool. Whatever. That's perfect. Let's move on. Okay. Oh man, that took 40 minutes. Really? Holy cow. Okay. Well, it is what it is. 50 minutes remaining in the contest. Q1 took 40 minutes. Holy cow. Okay, yeah, I need to get going, obviously. Go get some my coffee. Okay, let's start jamming. Get a move on here. Solve one so far. So here we go. Oh, music here. Not there. Okay. Okay, so Alice managed a company that's rented some floors of office space. Says some floors should be special floors for relaxation. Okay. Top and bottom. Inclusive. All right. Return the maximum number of consecutive floors without a special floor. The following arranged is inclusive of consecutive floors without a special floor. Special floors, are they sorted in monotonic completion order? No. 6 to 8. So should just be able to do a linear scan and then right for I to J. I think that works. Oops. All right, so 643 or 633, 40, 634, yeah. Okay, so we'll sort these special floors in monotonically increasing order and perform a sliding window. Does that work? Hold on. Start at 2 and then so 2 to 4 non-inclusive. All values is special or unique. Wondering if there's some kind of weird edge cases I have to watch out for, like if top is less than special. No. Top has to be at least bigger than special. Okay, so that makes things a little bit easier. Okay. Let's do this. Low, high. Integers. So array of specials. Right. Size 0. All right, I equals low. How about J equals a sub 0 after sort. Problem statement doesn't say whether or not that's sorted or not. Okay. J is that guy. Okay, so while J is less than I is less than I. Try the best. Best. Okay, so candidate is J minus I non-inclusive. Maximum best candidate. Bottom J. All right, so just check that first part and then the next part, next chunk. Next chunk, next chunk. Stop. So I don't think we need to end. low is less than one of those guys, right? So there's a candidate. Actually, let's do this. Let's make life easier on ourselves and let's just modify the array, right? And then look at the adjacent difference, right? Remember KSS, keep it super simple. Let's just push low to front and high to back. Let's see, using deck integers. Deck estimate maximum adjacent difference. Max element. And these are the deltas. Adjacent differences. Okay, and then let's do this. Sort that guy. Deck a a like this, naming let's get that way, right? And then let's call this one. I don't know if I'll go just a list. Candidates list. I want to call this thing B. Whatever, B for me, and then D for me. It doesn't matter, I guess, right? Deck B from A. B dot play ipsum push front low B dot push back high. Adjacent difference B dot begin B dot end insert T dot front. That should be fine, right? Whoa. Yeah. 3 is correct. One should be 0. 3 and 1 is not correct. 1 is not right. Adjacent difference. Special floor not included. Not included, right? Every floor rented is a special floor. Maybe I did this I was thinking about this wrong. Uh-oh. So originally I was thinking, yeah, just sort it, stick the low to the front, high to the back, and use adjacent difference, but that's not right. It's not inclusive, so it's adjacent difference -1. Top is inclusive, bottom is inclusive. So -1 and +1, right? +1, and then subtract 1 from this thing. That looks good. Yay. Okay. So I don't know, I'm gonna clean this up a little bit, or yeah, whatever, it's fine. Let's post this and move on. Use solutions. Turn the maximum adjacent difference. Which turn the maximum adjacent difference. Of the input array a with low and high. The inputs as prefix and suffix correspondingly. Right, that works. Just try to simplify it for ourselves. Life a little bit easier on ourselves, hopefully. Let's do some Python. Hello, there's an array. A equals low plus A plus I. Okay, so just pin that to the front and the back. Right. Oops. Line range 1 to A. Candidate is a sub I minus a sub I minus 1 minus 1. This is inclusive. The best candidate, right? This goes maximum itself. Candidate, best end. That's not right. 1 is not correct. That minus 1. Is that right? Let's hold on. Let's do this. 2946. That's the first one. Okay, so this one is 2. So that's 3. So that's right. The other one's not right though. 6, 8. 6, 8. 7, 8. 0. Wait, did I have this wrong? Hold on. 3 and 1. Why is it returning 0 now? Best. Oh, I haven't sorted it. Okay. Sorted in between those guys. That looks legit. Okay, cool. Yay. JavaScript. Three. Yes. Okay. And then actually, let's clean this up a little bit, right? We can make it kind of cool, right? To the maximum of all those things. All right, so that works. And then clean this up a little bit even more. Don't need best. Right, we don't need best here. Turn maximum. Yeah, it's an okay solution, right? Not too shabby. I don't know. I can like this solution more. It's not as squished up and stuff. It's easier to read, right? It's cool. Whatever. Then same thing for C++, right? I mean, I guess we can clean this one up in the same way. And then just do a linear scan. Yeah, whatever. It's just fine, whatever. Yeah, it doesn't have to be perfect, right? Let's move on. I'd like to get to Q3 and Q4. Focusing way too much time on the easy ones. And, focus more of my time on the hard ones, right? So whatever. Just do this one functionally as well. Okay, so a dot sort. Right, sort it in automatically increasing order, and a equals on a dot unshift low a dot push I. Right, stick it to the front, stick it in the back, and then return index check. Right. Raise length and length. Please. Yeah, pitch index. Just one. No, it's fine. Yeah, whatever. This one compared to that one. Each index I. Okay, so I plus 1 minus a sub I minus 1. Return the maximum of that. Okay, something like that. Well, that's all right. Oops. So log a 246. Oh, plus 1, right? Plus 1, since they're inclusive. That looks good. Okay. Stick it there. Okay, Kotlin, you're next. You're next, buddy. Okay, low. Sorry. Okay, so RA is a mutable list of integers, and it's going to be low minus 1 spread operator of A, I plus 1. This one I want to be sorted. Sort. I wonder if this works. Sorted. And return its array sub a dot size with it, the index will map size minus 1, map each index to a sub it plus 1, I say sub it minus 1 max. Okay. Whoa. Sorted. To int array. Come on, big money, no whammies. To array. Right. Oh, to, hold on. Typed array. Big money, no whammies. Here we go. Yay. Okay. Kotlin. Of these sorted. At this sorted input array A. Pended and all right, prepended, right? Prepended and ended as that works, right? Return the maximum adjacent difference to the sort of input array A with inputs low and high prepended and appended correspondingly. Right. It works. And then let's do the rest real quick and move on. Right, it doesn't have to be perfect. That's good enough, whatever. Okay. Okay. Let mute A equals a vector. A dot push low. Rust copy vector. Let's see. The pin vector onto a vector. Right, I want to extend it. Extend A dot append mutable B. That looks good. Extend. And pass a mutable reference. Avoid the move. And the move is fine. For here, it's fine. A dot pinned. A dot push high. And then look at the adjacent differences for I in one until a dot length. Best. Let me best 0. My candidate go a sub I minus a sub I minus 1 minus 1. Oops, these are inclusive. Best equals max, best candidate goes to the comparison max. Okay, let's see what happens here. Big money, no whammies. Oh, types differ immutability. Expected mid-war. Oh, okay. If I to be immutable. Right, okay. Stack Overflow mentioned. Three. One is not correct. Okay, because I did not sort it. Okay, so a underscore dot sort. Whoa. Okay, fine. Mid-will vector. And move it there, right? Whoa. Cannot find value a underscore in this. Oh, oops, this is the type, and then this is the mutability. The syntax is like really strange. Types differ in mutability, mutable reference. Okay, fine. Zero looks good. Big money, no whammies. Yay. Okay. All right, not too shabby. The best solution, but not the worst, I suppose, either. It doesn't have to be perfect. Alrighty, and we have 21 minutes Q3. Q3, okay. 21 minutes remaining in the contest. So it's Q3 time. And I'm gonna grab some more coffee and then start this one next. All right, I've got a food coffee and it's Q3 time. Wise and of an array nouns, bitwise and of all integers and numbers. Okie we give an array of constant arguments. Okay, cool. All right. Evaluate the bitwise item of every combination. Each number of candidates may only used once in each combination. Return the size of the largest combination. combination is bitwise and the size of the combination is 4. Larger combination is bitwise and 8. The size of the combination is 2. This and is 1. Size combination is 4. So we want the largest grouping with the bitwise and greater than 0. Bitwise and greater than 0. So n is 25, 100,000. We're looking for a near linear solution. Hold on. 7:05 a.m. Our minutes for game plan. Okay, so since n equals 25, it's 100,000. We are looking for a near linear solution to avoid TLE. And the whole thing's together. We just use union find, right? Use union find to create connected components. All values grouped together. Results and bitwise and greater than 0, right? They have at least 1 bit in common. Does that work? A bit in common, the bit they have in common is 16. It's whatever that is, right? I wonder if that's right or not. I don't know. I think so. Yeah, let's try. Whatever. All right, 7:07. 2 minutes or so for the game plan, right? And then let's just implement it, see what happens. It's for implementation. Let's go. Okay, so size P sub n. So parent representatives of the set and disjoint sets. Iota. P up again. And sort of 0. And then find will be recursive. Undefined. Capture stuff recursively. Lambda. Turn piece of x equals x. X other is fine. Piece of x, right? Path compression. Union. Capture find. Equals find A. Find B. if A is not equal to B, and the parent of A is B, which is an arbitrary choice. Oops. Let's do dice here, arbitrary choice. If you, so then that's fine. Union. How do you kind of compare the bits though? Maybe I should be using a try. Okay. Use a try for each of these things. Use 0, 1s and such, but does that help? I don't know. Buckets of common bits. Maybe buckets of common bits. 0 through 31 inclusive. I think that's better. Yeah, let's do that. Hold on. Remember. Come on. Yeah, but hold up. Bitwise comparisons. It would be quadratic, right? Okay, so let's choose buckets 0-32 non-inclusive 0 to 31 inclusive. Then count size of each bucket. I think that would work. Right? Okay, let's just try. All right, hold on. Remember, kiss, it's super simple. Let's see how much time we have. 11 minutes. I think we can do this. Come on. 11 minutes remaining. Contest. Let's go. Time to shine. Okay. Gets using map as a bucket. Integers. Okay. Best man. Or X neighbor A for each bit 0 to 31 inclusive. 32 non-inclusive. If X and 1 bit should be left by I, then M sub I dot push back X, and then for each bucket count in the map. This is the maximum best count. Maximum. Bucket size. I suppose we don't need to push it back. We can just increment it, right? Candidate. There's our candidates. Right. Oh. Yeah. 4. Okay, that's right. 4 and 2 looks good. Yay! All right, that's awesome. I was doing something way too complicated. Say, hey, there's probably an easier way to do this. Switch tracks, hit it, bam. That's awesome. Okay, cool. I doubt I'll have time for Q4, but we can finish up Q3 with all the other languages here. A few solutions. Use map to count each bit bucket from 0 to 31 inclusive. Kotlin. JavaScript. 3. Rust. C++. Okay. That's cool. And Mr. Counter. XA for I in language 32. If X and shifted left by I. M sub I, this goes 1. Turn, let's see. Turn the best in the end. Oops. Best. Or which candidate, and I should just return the values, right? Return max, end up values. Spread. Int object is not iterable. What? Does that work? 4 and 2. Right? Okay, cool. Yeah. Oops. Python 3. JavaScript. These are candidates. And there's a new map. X of A. I equals 0, I is less than 2, non-inclusive. X and shift left by I. And set I 1 plus and get I for 0. Turn and dot map. Count the maximum of that. All right, looks good, looks good. And boom. Go. Kotlin. And this mutable map of sure buckets. Turn m dot map count x for x and a for I and 0 to 31 inclusive if x and 1 shifted left by I not equals 0, then we'll do m sub I equals 1 plus m sub I plus 0. Big money, no whammies. Uh-oh. I'm not expecting. And all right, big money, no Emmys. Yay. Okay, Kotlin, JavaScript, Python 3, do Rust. Let's see how much time we have left. 3 minutes. We can do Rust in time, I think. So where's gonna find it? Where's Rust? Okay. All right. So let mute m equals hash map. Use the functions hash map. Okay, and then for x8, for in 0 until 32, non-inclusive. If x and one shift left by I is not equals 0, then m original location m dot entry of I or insert 0 plus equals 1. Okay, and then best equals 0, best in the end, or and count right in m best equals maximum best count. Right. Use comparison maximum. All right, let's see what happens. Oh, nice. Yeah, first try. Usually I have to mess around with Rust and get it to compile, so that's cool. I wonder if I can clean this up a little bit though. Oops. Let's see. Rust hash map values. If I could iterate through the values and turn the maximum, that'd be cool. Can I just return the values? The values, cool. Let's do this. Turn in dot values dot header dot max. Does that work? I don't know. Let's see. Specs. Dot values dot max. Oh, specs dot 32 have option. Dot unwrap. Uh-oh. Expected I32. Okay. Dereference that guy. All right, big money, no Emmys. Yay. All right, cool. I think that's all she wrote. Got 3 out of 4, 10 seconds left, just in time. Use a map m to count each ith bit bucket from 0 to 31 inclusive. It's cool. I wonder if I can do this. C++ unaltered map values. Get the values, I don't know. I don't think so. Bucket size, what the hell is this? Again. Yeah, it doesn't have to be perfect, but you can just for consistency, you can use like, I don't know, count. It's cool, whatever. It doesn't matter, I guess, right? And these are counts I'm using here. Consistency, might as well use count, right? Count is the best candidate. A little bit cleaner. Okay, cool. All right, that's all she wrote. Catch you next time.